At this point, oh, by the way, this is page 96, and we're going to relate the z-scores and how they help us with the normal curve. So this is, you've got to make sure you have a good understanding of z-scores, and just been introduced to the normal curve, and we're going to start relating them. You know, and at this point, after the last video, when I said there's an infinite number of normal curves, and I showed you that they had the normal curve followed the formula that looked like this. Some of you probably looking for the counselor, and I'm going to say, hold on, you're going to be fine. Ultimately, we're going to do so much work with this, not now, but with probability, that the normal curve will be very easy. And like I said, it's one of the most important things. And they also have some very similar characteristics, because regardless of the center of regardless of where the center is located, regardless of how spread out the data is, etc., we can say that about 68% of the data lies between plus or minus 1 standard deviation. About 95% of the data plus or minus 2 standard deviations, and about plus or minus 3 lies within 99.7%. Now, this right here, you need to memorize. Plus or minus 1 is 68, plus or minus 2 is 95, plus or minus 3 is 99.7. And this has a name. It's called the empirical rule. All right. And these are our abouts. We're not perfect in statistics. And so the question is, well, wait a second, how did that come? Where did that come from? Well, first off, you have to kind of understand that probability is an area. And so they took the area under the normal curve. But once again, that involves calculus. We're not going to have to do any calculus in this class, so don't worry about that. So they integrated this, and that's how they found those areas. Now, for right now, we're going to use a table, and we're going to take a look at this. We're going to look at the plus or minus 3 first, and then we're going to look at the and then we'll do the others as well. So first off, you need to be looking at your table, which I gave you all. It's up in your Google Classroom. And if I just look at -3, it's like, oh, -3, 0, 0 gives me 0.0013. Now, one thing you have to understand about the table is the table works from left to right. So the table works from left to right. So basically, we have and these are based on standard normals, and don't worry about that right now, but they've centered everything at 0. And so basically, we have a -3 down here, a -2, a -1, a 1, a 2, and a 3. And technically, it goes on to infinity, but like we said, 99.7% lies in plus or minus 3. And you're like, well, where did they get that? And I go, well, I look at -3 and I see 0.0013. And I actually drew that out, all right? So -3, and I said 0.0013, okay? So what is a +3? Because I need the area between -3 and +3. Well, if I look at the positive chart, and I'll slide all the way up to +3, I see 0.9987. And what that tells me is everything below everything below 3 is 99.87, or 99.8% of the data lies below it. So these are percentile ranks. The table is percentile ranks. So this is 0.0013, which is 0.13% of the data lies below -3. Here is 99.87. So 99.87% of the data lies below 3. If I subtract those two, I find the distance in between, because I want to subtract out that tail. So I subtract out that tail of 0.0013, and I end up getting 0.9974, which is, it's close to 99.7%. So plus or minus 3, we have 99.7%. Now, that's the first time you've looked at a table. This is the first time you've looked at that. So it's probably still a little confusing. So let's look at -2. Let's do ±2. Well, ±2, I'm looking at the table and I go, okay, where's -2? And I see 0.0228. So I'm going to write that down, which I did on my sheet of paper. And I say, okay, this area below this tail is 0.0228. So about 2.2% of the data is below that. So my percentile rank for -2 is about 2.2%. And then I need to go all the way up to +2 because we want the distance between the two. And at +2, I find 0.9772, which I've also recorded, 0.9772. So I'm going to subtract out this tail because I want the distance between. So the 0.9772 counts all of this because it works all the way from the left all the way up. And I subtract, and I get 0.9544, which is 95%, approximately 95.4%. If you wanted the real 95%, it wouldn't be ±2, it'd be ±1.96. But the empirical rule, close enough, good enough for our class, good enough for most of the world, actually, it's used all the time. ±2 is about 95% of the data. And you're like, okay, let's do ±1. All right, at ±1, we need to go look at the z-score for -1. And the z-score for -1 is 0.1587, which I recorded over here. So there's the 0.1587. And then I need to look up +1. And +1 gives me a z-score of 0.8413. So 84% is the percentile rate. 84% of the data is below +1. So when I write that down and subtract them, I find out, it's about 68%. So about 68% of the data lie between -1 and +1. And this gives me, this right here is where I come up with the empirical rule of ±3, 99.7. ±2 is 95, and ±1 is 68%. Okay. Now, one more thing about the table, and we're going to spend more time with the tables because we're going to teach the tables at the beginning of the year, and we'll show you how to do in the calculator during probability. The body of the table, or the outside, the rows and columns, make up the z-scores. The inside of the table are percentile ranks or probability. Percentile ranks, or you can refer to them as probabilities, okay? All right, so previously, when we talked about z-scores, we did the chemistry and calculus problem, and I'm not gonna go back through that, but one thing I wanna show you about the chemistry and calculus problem is that the chemistry had a mean of 75 and the calculus had a mean of 80. So essentially the centers were shifted. Not only that, this had a standard deviation of 12, this had a standard deviation of 8. So the calculus had a narrower normal curve than the chemistry. The chemistry's data is more spread out. And you can look, it ranged from 39 to 111, whereas the calculus ranged from 56 to 104. And basically, and you're like, well, where did you get those? And I said, well, 99.7 is ±3. So I took 75, subtracted 12, subtracted 12, and subtracted 12, added 12. All right, so I went ±3 this way, I went -3 this way, up 3 this way. Did the same thing here, but now I'm working with 8 as a standard deviation. All right, so 72, 64, 56, adding 8, and that gives me my spread of the data. So I know that 99.7% is between 56 and 104. 95 is between 64 and 96, and 72 is between, 68 is between 72 and 88. Here, 68 is between 83 and 87. 95 is between 51 and 99, and 99.7 is between 39 and 111. And I don't know if they gave extra credit or not, but that's the way that would actually work. I'm not going to rework this problem because this is what we previously did. All right. Thank you.